Hello, my people. Welcome back to video number 2. I hope your hands aren't dying yet because there's a little more, there's some more to go. So now our main topic of this lecture video is the nervous system. Okay, so within our body, we have two main systems, okay? We have the central nervous system, which I abbreviate to CNS, and then we have the peripheral nervous system, which, yes, it's a little funny, but you have to say it slow. PNS. Don't say it fast. Don't say it faster. And if you do, you'll see what I mean. So we have the central nervous system, and then we have the peripheral nervous system. Okay. And so what are these two? How can we kind of see they both conquer really big parts of our body, and they control really different but big parts of our body. Okay. So in the nervous system, we have central nervous system and the peripheral nervous system. So real quick, the nervous system is, it's the king. It's the king of our systems. It consists of all nerve cells. That's where Nancy is, right? Nancy's part of the nerve cells. It is the body's speedy electrochemical communication system. So the nervous system, imagine the nervous system as your main highway. Okay, it's like how your body functions. And within the central nervous system, we have two key players, and they govern two different parts of our body, but they are important. They are needed for our survival. So we first have the central nervous system, and it's as simple as this. It's in charge of two things, the brain and the spinal cord, right? So the brain and the spinal cord, two very important things. I want you to kind of think of the spinal cord as the freeway. Think of your spinal cord as your neural freeway, and the central nervous system is very, very fast, right? Very, very fast. And everything else, other than the brain and the spinal cord, is governed by the peripheral nervous system. So anything that's not your brain and spinal cord is the peripheral nervous system. And my mnemonic is kind of thinking of your like peripherals, where it's like you're looking outside of what you're like zoning in at. That's essentially what the peripheral system is. It's the sensory motor neurons that connect to the central nervous system to the rest of the body. So the central nervous system is the brain and the spinal cord, and the peripheral system attaches to the central nervous system, but it is in control of everything else. It helps govern it, right? And again, we will go through this, so don't worry. So just, again, central nervous system is in control of your brain and your spinal cord, and everything else in your body is governed by the peripheral nervous system, okay? So again, just to refresh, the three types of neurons, right? We have our sensory neurons. A synonym is afferent, but a lot of the times AP tests will call them sensory neurons. And it carries the incoming messages, right, up the spine, right? Up the spine. We're going to learn where it goes soon. But once it comes down, it is going to be motor neurons, right? So again, we have sensory that carries incoming messages up to the brain, and motor neurons carry information out of the central nervous system away from your brain, right? So if we think of your spine as a roller coaster, sensory neurons are going up, motor neurons are coming down, okay? It's a one-way freeway. You can't go, sensory neurons cannot, they can't go the other way. They go up the brain, right? So me sensing the cup in my hand, that message already went up to my brain, and my motor neurons are already holding my cup. Again, very quick, but it's an efficient system. And then again, the interneurons are the little messengers that help the sensory and motor neurons communicate, right? So again, sensory neurons go up. Interneurons kind of work around. Interneurons are also a part of our reflexes, which we'll talk about in another chapter. But motor neurons are the ones that are traveling down, right? So I have a little camera so you can see. Boop. So again, sensory goes up, motor comes down. All right. So now I want you to take some time and pause this video and please, please draw this hierarchy. This graphic is going to be perfect for everything you're learning during these video lectures. So please pause me and copy down this. We have our nervous system at the head, right? And it's split into peripheral and central. So again, central, all it controls is your brain and spine. That's its main duty, and that's the best duty, right? So central is only in charge of brain and spinal cord. The peripheral does everything else. So the peripheral nervous system, and we'll talk about this in our next slide, it's divided by autonomic and somatic. okay? And I don't want to get too ahead, but I want you to, so as you're copying this down, I'm just kind of explaining each one, and there's a slide for each of these, so don't worry. So if you're still a little stuck, don't worry. So within the peripheral, we have automatic and somatic. Automatic is controlled. This is involuntary control. This is done automatically in your body. So a perfect mnemonic is autonomic is automatic. Autonomic is automatic. This controls your self-regulated actions, your internal organs, your glands. So this is where your digestion, you're not telling your stomach, digest now, right? So these are all the involuntary things that your body does without command, right? So again, autonomic is automatic. And somatic is where all your voluntary actions are. So if you want to write voluntary there, this new book doesn't say voluntary, but it should be voluntary. And your somatic is in charge of things you control. So motor skills, me holding my cup, I can control that. Sensory input, I can feel things, right? So I'm in charge of that. But everything else, so like regulating your body temperature, digesting, breathing, those are all involuntary. So those are all controlled in autonomic. Somatic controls voluntary movement, okay, voluntary movement. And when we think of autonomic, which is automatic, there's two types that can be, so there's two branches that come out of the autonomic. It's sympathetic and parasympathetic. And right next to it, I would like you guys to write fight or flight response. This is where your fight or flight response lies, right in here, okay? Sympathetic is what arouses your body to action, and parasympathetic then calms it. So say that Sally ran into a bear, and we're going to learn about this in just a second. Her sympathetic system is going to kick in saying, oh gosh, like I need to, my heart rate's going to rise, my temperature is going to rise, my blood flow is going to go to my muscles. It's all automatic. And then after Sally makes it away from the bear and she starts to calm down, parasympathetic will start calming down your body. So these are all involuntary reactions, okay? These are all automatic reactions that our body has, okay? So again, please copy this down in your notes. It's gonna help you really understand this chapter, okay? Again, so a little bit more about autonomic. So, and you can write little notes within the box. So again, sympathetic arouses your fight or flight. So in your sympathetic, so if you look at right here, right? So sympathetic nervous system, your pupils dilate. So again, so say Sally sees a bear, your pupils dilate, your heart rate accelerates, your digestion slows down because it's not important right now. Your liver, it releases glucose, which is energy from your food. So you can actually run faster if you are in a fight or flight response. And then your bladder relaxes because the fact that you don't need to, you shouldn't be going to the bathroom right now, right? So it's like, that's the last of the things, right? And so again, these parts of your body are all part of the arousal part. And then we have our parasympathetic. So after Sally runs away from the bear, let me move my camera, your pupils start to dilate back, your heartbeat slows down, your digestion continues, like, oh, maybe I am a little hungry. Your bladder contracts again, which means, ooh, I need to use the restroom now, right? Because now that your bladder is working again, it's gonna see like, oh, I need to use the restroom. So this all happens within our autonomic system, okay? So this is our fight or flight. So think as the autonomic system as your fight or flight response. The fight, which is the sympathetic, right? So this is the arousal, and then the parasympathetic is what calms you afterwards. And that's why it takes you a while to calm down, right? You're like breathing hard. You're like, oh God, like I just ran away from a bear. And then you have to slowly come down. But your body naturally does that, right? And again, remember, when you are in prolonged stress, your body stays in this fight or flight, which is actually how you start to get sick, right? Because your immune system starts to go down, you're not sleeping as well because you're in this zone right now, right? So this is also where prolonged stress means that your body is stuck in this sympathetic part where it's like too aroused, right? You're like, something's gonna happen, right? So something to think about. And again, maybe make sure that I'm not going too far. Okay. So real quick, with the central nervous system, it's all interconnected by neurons, and it's complex, it's modified, and as you grow, more neural connections are being made. So kind of think of it as a freeway, but and soon we'll learn it. We'll learn about plasticity and how if our brain is damaged, neurons will start to find a way to reconnect. So if you've ever if you've ever had a family member or someone that has had a stroke and they lost their ability to speak, relearning how to speak is relearning how to build neural connections. And so every new skill you create or you discipline yourself with, it's more neural connections being made. And the more you do something, the stronger it is. So the more you play guitar, the better you get at it and the more you're able to do because your neural pathways are growing, right? Isn't that so cool? It's like a neural freeway. And, if something falls, it finds ways to reconnect. So that's where, rehabilitation therapy happens, if people are in a car accident and they have to relearn how to use their arms, our bodies are able to do that because our brain reconnects itself. It creates new neural pathways. How cool is that, right? And last but not least for this slide, just a few takeaways about the spine and why the spine is so, so important. It is the information highway, okay? Your spine, it gets me so nervous when, all these sports come out and people are like, oh, I hurt my spine. Ooh, your spine is the worst thing to hurt. And if you watch Grey's Anatomy, you know why. The spine is an incredibly intricate, it's intertwined with neurons. And if there's one simple slip of the spine, if there's a surgery, you could become paralyzed, right? Because your neural connections could be cut off. So people who are paralyzed, say from the body, from the from the hips down, it's because there is a blockage that your sensory neurons cannot reach your brain anymore. And without your sensory neurons reaching your brain, you cannot feel pain. You cannot feel, and because you feel pain in your head, right? And so if your sensory neurons are getting stuck from something that happened in your spine and they can't get up to your head, you cannot feel. And that is how paralyzation works. Your spine is the central highway to get to your brain, okay? And your brain, so your body, yeah, sure, you feel pain, but pain is processed in your brain. Okay, so our reflexes are governed by our autonomic system, and it's controlled through the spinal cord. So something that's really interesting, and it says it right here. So the pain reflex responds before your brain, and this is so interesting. So my ladies, if you've ever burnt yourself on a curling iron, or ladies and men, if you've ever burnt yourself on the stove, and also men, if you want to curl your hair, that's totally fine. But if you've ever burnt yourself, the first thing you do is pull away, and there's a split second where you don't feel pain. It's because it hasn't traveled to your brain yet. So your reflexes, your sensory motor actually bounces back from your spine, and your reflexes don't go to your brain quick enough. So as you're pulling away, your sensory motor neurons are still coming up to your brain to feel pain, and then you feel pain. Right? So reflexes are supposed to save you before your brain recognizes it. So isn't that so cool? So anyway, so just a few things about the brain, and I will stop this video and wait for your next one.